you can find us at the Kentucky mathematics.org website, and that website is full of all of the information that you know and love. So my agenda for today is we're going to take a look at the Kentucky standards, and those standards to me are beautifully written in a way that allows students enough time to simmer on the thoughts behind multiplication and division of fractions, but also in a way that connects them across the grade levels. And so if in Kentucky, and again, they are based on, they are indeed based on the Common Core standards, but if we really pay attention to the words that are in those standards, we'll really see some benefits for our students. Going back to the 3 books, you'll see me reference those 3 books. We're going to talk about those progressions, and then we're going to do a little bit of fraction division there at the end. Interspersed through all this, I've got some resources that I hope that you will enjoy. So today I thought about you guys grabbing a Post-it note, and so I'm taking a look to see that you guys, maybe have grabbed a Post-it note. And as we're going along, I'd love for you to write down 3 things that capture your learning experience today. So thinking about what resonates with you as we are having these conversations. And I appreciate that on this Friday afternoon that you guys have joined me this afternoon. And of course, I love seeing what you guys are talking about in the chat box. So let's get started with our standards. The first standard where we have an entry point with regards to multiplication of fractions is right here in 4th grade. And these 2 words, apply and extend, are so important at the very beginning of the standard. So I just wanted to really kind of hold that thought for a minute, because students should not have something new in their mind with regards to multiplication of a fraction. They should be taking what they know about whole numbers and extending them to include fractional thinking. Indeed, they need to understand that the fraction, for example, 3/4 is 1/4 plus 1/4 plus 1/4, or 3 1/4. They should also think about it understanding what that is, all right, thinking about as they are multiples. And then of course, I love this last one, solving word problems. And that's going to be the thing that I'm really bringing to you today. And that is that we should be teaching fractions in context, and in more context. So let's take a look at how it progresses to 5th grade. So you can see that you're interpreting the fancy fraction, really, all right? Thinking about that fraction, 2/3 times 4, what does that really look like? Here's a clarification. And thinking about it in terms of area of a rectangle. That, of course, is the famous area model for multiplication of fractions that brings some context to that. We're also looking at solving with multiplication of fractions and with mixed numbers. And then, of course, a very deep thinking about that entry point with regards to division. And what does that division really look like? So I've really boiled it down to these are the things that I think that are important. Apply and understand, apply and extend the previous understanding from multiplication, and thinking about it from whole numbers to fraction and from division to whole numbers. Here's kind of a quiz for those of you that keep attending every afternoon. So if we were going to do whole number multiplication, I'd like for somebody to unmute and say to me, how did kids begin to think about 2 times 3? What do you know about that progression? How do kids think about 2 times 3?
You start with repeated addition.
Ah, Ah, very good, Jennifer. I knew that you guys would remember that. That's just the natural part, right? You start with repeated addition. Dee had a beautiful session. Was it last week, Dee? Was it last week? Talking about, maybe 2 weeks ago, talking about the power of skip counting. Very good. Kim says, yep, I see it, skip counting. Lucy says, I see equal groups. And even think about it as equal groups. That's exactly right. So remember, the standard says apply and extend. So guess where we're going to start? All right, we're going to start with making sense of those fractions from our document. We know that the IES document is our favorite, and we know that we want to start with that skip counting, because I go back here to my book, and I'm gonna hold it up every time, and that this book says teach meaning first and algorithm last. So I'm looking in the chat, I'm looking for someone to unmute, because you know how I like to have that conversation with you guys. Why is that crucial for fractions? Teach meaning first and algorithm last.
Well, I can tell you from a personal standpoint that I was never taught meaning in fractions, and I absolutely did not understand the algorithms, and fractions were a mystery to me.
And so they were magical dust that your teacher sprinkled, and forget applying them. Remember, Leah last week talked to us about, no, as a matter of fact, Leah talked to us Wednesday. Do I have my day right? I think so. Wednesday, about how this fractional understanding extends into high school. So you're right. You're exactly right. You have to teach meaning because you'll have a better chance of being able to do that application, says Kim. You want that conceptual understanding. And of course, Amy telling us that, you know, we absolutely have to have it because that's what's important. So think about how this is so important. This, if you don't come away with anything but this part, I really want this to be in your soul, that from practice and research and long-standing rule-based approach to teaching fractions doesn't work. We have a long history of showing that that doesn't work. Students need the time to process that information, and students really need to construct their meaning, working with concrete and visual representation so that they have a good sense of that. And so we're really going to take a look at that. Adding equal groups, that skip counting, indeed. When I had you guys unmute just a minute ago, notice how all the research tells us that's exactly where we start. We know that fractions are numbers. And so in multiplication of fractions, we are going to do two words: apply and extend what we did when we were doing with multiplication. When we were doing whole number multiplication. So let's take a look right here. Imagine that if we were going to think about 1/4 3 times. The skip counting of that is, of course, 1/4 plus another 1/4 is 2/4 plus another 1/4 is, of course, our 3/4. So I want you to take a look at these interesting skip counting activities. And my question to you is, what evidence do you have that students are making sense of the skip counting sequence? I'm looking in the chat. And I'm also looking for some of you guys to unmute and talk to me. This is a skip counting activity that's done in the classroom. It was a really, really good thing. You're right, Leah. Leah, what? Unmute for just a minute and tell me, what do the colors say? What did the kids are grabbing a different color. And so kids are doing what? So what do you see, Leah?
In my opinion, the different colors, like in the first picture, show 1. So they're recognizing that we're getting to a whole piece here with each change in color from red to black. So
I saw that too. And I thought, how powerful. Notice that they're not doing the simplified version or the reduced fraction in each one of these, but they're simply saying 1/4, 2/4, 3/4, 4/4. That's 1. 5/4, 6/4, 7/4, 8/4. That's 1. Can you make sense of what's going on over here? Who can talk to me about this? What's this little pumpkin doing? I felt like this one was amazing. And I see it's a dab bit blurry, but if you look down here, you can kind of see what they did. I want to take a stab at it.
So each color, I'm sorry.
Go ahead. I'll take either friend.
Okay. Well, I was thinking they're sort of thinking of more as a mixed number, right? Looks like the reds are just 1/4, 2/4, 3/4, 4/4. Now we're going to switch to the greens and think of it as 1 1/4, 1 2/4, 1 3/4, 1 4/4.
Yeah.
And so now we're switching, but I'm trying to think of those labels because it's sort of the third grouping, but the two. So then I think the black is where maybe some of that gets figured out below hand. Is
Isn't
so
that
the mixed numbers are really relating.
I thought this was very interesting that they had this idea that this is the ones, and then there's your transition time, time to put my marker down, change another marker, take off. And I thought, first of all, I thought, what teacher has this many markers that shares them? So I thought that's fantastic. And so I just loved the thoughts of it because I thought that the visual color helped with the skip counting activity. So when I bring you activities, I think about something that that would solidify and that has a conceptual understanding based on what you're asking the kids to do. I just thought that was marvelous. Just thought it was marvelous. So the first activity that I want to talk about is this idea of the fact that pattern blocks really are one of our favorite things to use with students and fractional amounts because of this idea of what is one. And so I'm going to go to a Glencoe tool, but then most importantly, I kind of want to highlight that I adore a site because I have a vested interest in it, in a site called toolsfornorthcarolinateachers.com. I kind of see it as the Boulder Valley resource that was shared that had a lot of assessments. This one happens to be a site by a lot of great folks that was built that have a lot of ready to use teacher materials. And so if you open up my handout, you'll see that I've pulled out a bunch of stuff from the website, but there are 100 times more resources for you at each grade level that are there for you as a teacher. So that may be one of your go-to sites for some student ready. But notice what this says. It says if a trapezoid equals one whole, write an addition equation and a multiplication equation for 4 green triangles. So I'm going to go ahead and go to, this is the Glencoe Interactive site. And here's what it's asking. It says, all right, if that's 1, let me go back to my question. Green triangles. All right. So if that's 1, I'm going to drop this back in here. Notice I can put it in the trash can and it goes away. Then what are the 4 green triangles? So question that I have for everybody, what is 1 green triangle? Look it in the chat.
1/6.
Ah, beautiful. So I'm going to pick up my pen and I can write in that is 1/6. And my question was asking me, how many green triangles?
4.
4 of them. So I can have my repeated addition. And then I'm going to be looking for you guys to type in the chat. Then what is its equivalent multiplication number sentence? So I'm looking in the chat. So here is physically what it looks like. I change back to my hand, I click it, I turn, and I can drag my triangles here, or I can just do that there. Look at Jacqueline, she's got it. Jacqueline says, indeed, what I've got is I've got 4 1/6 pieces, and indeed 4 1/6 pieces looks like this. And then by conceptual understanding, we can take it, drop it into our drop it into our hexagon. And as we put it into our hexagon, we don't even have to compute yet. We can actually see what the answer is. And so I can see that maybe I need a little work with my fine motor skills as I'm trying to stick these in their spots. But you can see that indeed that's going to equal my 4/6 piece. Imagine the power of the fraction plus the repeated addition to then get this deep understanding of 4 times 1/6. And this is where our students should be starting. Okay, this is where they should be starting. This is what they should be. This is what they should be thinking about. So from my book, I did find this question, and that is one that I'd like for you to ponder. And then I want to show you how we can think about it in regards to our virtual manipulative. So on a field trip, a teacher brought some large sandwiches for her 9 students. Each student got 2/3 of a sandwich. So the question is, how many sandwiches did the teacher bring? So I propose this visual model for students thinking about it, especially if the progression is going from working with fraction bars. So who can talk to me about what's up with this visual image? Why might we choose that as our visual image? I'm looking in the chat. Somebody can unmute. Why is this piece a 2/3?
Well, you got 9 of them, and that's representing, if you had one more, you would have a whole, which would represent how many sandwiches you need to, the teacher needs to bring.
Okay, go back. Oh, I see Cindy. Cindy says if the hexagon is a whole, she's exactly right. We can go back to my manipulatives. You're going to see why I love this. I just cleared the background. Oops. I can clear the background here. I grab my hand and I can clear the background. And so Cindy's right. There's my 1. And then of course, these are 2/3. And for a student, remember, we've just asked them to think about fraction pattern blocks. And so this is a nice way to do this. So what then might the answer be? So this is 2/3 9 times. There's 18/3. I can see those 18/3. But then what can a student do to really get just kind of an answer? Talk to me about how I could, if these were my virtual manipulatives, how could I rearrange those to get an answer? Jennifer says I can take some of these pieces and move them around. What else might somebody else want to do? Amy says I wrote down 2/3 9 times, and then I look to distribute those across to see that I can make them. Lisa says if this is what I have, I know that I can move them around and put them in groups of thirds, and then that tells me how many whole sandwiches I need. Because remember, what we're really looking for is how many whole sandwiches. And notice that, remember when I started, I said everything needs to be embedded in a context. We now just did a really hard multiplication of fraction problem, 2/3 times 9. That's a hard one. But because we did it in context, it actually is very easy for the students to see. You got it. Carrie says, I multiplied out how many pieces I had and then I divided. So she's thinking about this idea of 18/3. So Carrie, one of the things that I would say to you, if we were doing a number talk, I would press on you and I would say, well, why did you divide? And so what does that dividing mean? So can you think about?
Okay, I just unmuted instead of typing. To me, in my thought process, it would tell me that it takes 3 to make the whole, because that's what the denominator is. And so I would think, okay, I need to know how many pieces that I have total, and then I need to make a whole sandwich. So my groups or my whole number would be 3. So I need to see how many groups of 3 that I can make.
And Carrie, you just did multiplication of fractions, and the fraction equation was 2/3 times 9, and all of a sudden you made it very easy. And so now notice how everything has context. In this idea, remember the teacher in the classroom would say, you need to make sure you reduce your fraction. Like, well, what does that really mean? And the question then is, how many whole sandwiches do we need? How many wholes do you have? But then how many pieces in each whole happens to be a third. So you can see how indeed linking those, linking every single thing, and I'm proposing like this very utopic world of saying every question you give kids in 4th and 5th grades needs to be linked to a real world context, or they need to have a naked number and make a real world context associated with them, because the standards give you the time to simmer and to think about that. So I found a series of little videos. I'm watching my time, so I'm gonna be very selective on which ones I find, but I know that some of you like to circle back. And I knew yesterday when I was going down the rabbit hole with some of this, that I would have too much stuff, but this is a really nice instructional video about thinking with regards to multiplication of fraction and giving some visual images. This is one that I wanted to do because in honor of the fact that KCM adores a number line, we often will think about multiplication of fractions in area models, but this is a really good one for a number line. Go back.
5/8, 6/8, 7/8, and of course 8/8, or 1 whole. And then what we need to do here is just, this is when we have 1/8 3 times. So just go 1/8, 2/8, and then 3 times. So we jumped basically 3 times on this number line of 8s, and we would see that that would be 3/8.
So I want to stop right there with that one and tell me, and just have a little conversation. How is that different than the pattern block? How is using a number line a different tool? It's a conceptual understanding and it builds the idea of multiplication, but how is this different than the pattern blocks? And why do you really need to know, why do you really have to do 2? Why do you have to do both of them? Amy says that it's linear. She's exactly right. Thinking about it in a linear way. And you know what? It's not a physical model, right? They're not touching this. This really is thinking about it in a linear way. So I propose that when you are teaching multiplication of fractions, you have to think about these variety of tools and what each tool allows kids to see. But indeed, Kim and Cindy, the number line is a little more abstract, but it also feels right to a student because they've jumped on a number line adding, they've jumped on the number line when they're doing whole number addition, they've jumped on a number line when they've done whole number multiplication. So now they're going to jump on a whole number line, when they're doing fractions, and all of a sudden this method feels very, very familiar to students, and that's exactly what we want. I've incorporated in your materials some really good questions for kids to be able to do. So I did think that students need to recognize the type of multiplication that they're doing, and these ones tend to highlight fraction by a whole number. So take a look at the blueberry pancake party activity. So Todd's having some friends over. He's got 6. The recipe serves 6. He's going to have 24. He's going to have his classmates over. There's going to be 24 people. So how much of each ingredient does he need? So you can see that Todd needs to think about this. He needs to multiply out. And again, I've gone back to the Glencoe interactive virtual manipulative board, and students can create the recipe. So this one is for flour. You can see that they needed 1.5 cups of flour. I needed it 4 times. There's 4 cups of flour. And then as I circled my others, you can see that in total I needed 6 cups of flour. So this is something that I did on that virtual, that Glencoe virtual manipulative. It's really that I was able to drag things. They have certain colors. They go along with the colors on some sets that I have. So I really love that virtual manipulative. Here's what I know you guys are going to love. And I see my friend, indeed. I see you, Mary Kate. So Mary Kate Duncan is in here, and indeed she uses Glencoe Interactive in her class. This is a game called Zach's Zoo Adventures, and it is multiplying a fraction by a whole number. And I know that the font is a little, is kind of small for us to see, even if you're looking at it, but I'm going to tell you that it's pretty straightforward. You have a dice, you roll your dice, and that dice tells you how many times to multiply each of the different fractional amounts. So think about that. This is a zoo, and this could be the Cincinnati Zoo. If it's in our area, it happens to be the Asheboro Zoo. This is another one of those that is located in the Tools for North Carolina Teachers website. Amy says she likes the Z. But imagine that you roll your dice, you get 5, and it's 5 times 1/4. You have to do the math problem correctly, and then you get to move that many spaces. If you rolled a 5, you get to move 5 spaces if you get the math right. So Jenny Bay Williams tells us that math games really, really, really help students increase their fluency. Here's another one, another game for you guys that's located in your packet. And this game is called Parts of a Whole. And if you scroll down in your packet, you'll see that I've given you both a fractional spinner. And then this one also requires a dice. So you can see right here that it says roll and spin, and you make an equation. And then if you get over 1, you get to grab a star, and grabbing the star, it's the one with the most stars at the end wins. So in the chat, if you're looking at this one, which is multiplication of fraction, this is a fraction by a whole number. And then this other one is again a fraction by a whole number. How might students, how might this be an advantage over a worksheet? Looking for that in a chat. Why would we want students to play games like these? Why is that an advantage over a worksheet? Yep, indeed, much more open-ended. Oh, way more engaging, Bill, aren't we right? Yeah, much more engaging. Same amount of math, right? They're still doing 10, 15, 20 math problems, but they're really having to think about it. They're not the same old problems, and it does move to differentiation. So now I'm going to switch to thinking about whole number by a fraction. And in our Van der Waal book, and I told you I was in all kinds of books developing this. In our Van der Waal book, one of the cornerstone problems that is in there is how big is the banner? And you ask the kids this, 6 times 1 foot. How many feet? What is the square footage? Because they've done a lot of area models. How many square feet do we have in this banner? So one of the things that I want to encourage you to do, that when you're giving kids math problems to solve for multiplication of fractions, please start with numbers that are known and that are familiar. Because look what you can do then. You can now ask the question, all right, fine. If the banner is 6 times 1 is 6, duh, Miss DeLong, of course it's 6. Then what's it going to be if I only have half the banner? So what would 6 times half be? And you're right, Amy. This does provide an entry point for every student, right? Every student knows 6 times 1 is 6. And then if I have half of that amount and you have a visual picture, at that grade level, half of 6 is going to be the 3. And so we're doing multiplication of fractions without ever doing an algorithm and without ever really having to say some sort of way that the teacher told me to do it. It is a beautiful entry point for most folks. So now I'm taking a look for some more resources for you, continuing with my theme of giving you some things that I know intimately, and that's with the Tools for Teachers. And so Molly has a goal of training for a 5K. She's going to run 10 miles by the end of the week, and on Monday, the distance that she wants to run is 1/4 of her goal. All right. Why is this a different way of thinking? The other ones I said were, I've got 1/4 3 times, I've got 2/5 4 times. Why is this? How is this one different? I'd love for somebody to unmute and tell me a little bit. Why is this one different for kids to think about? 10 miles, and on Monday, the distance for her goal is she's going to run 1/4 of it. What's the difference? Stacy, you get my Friday afternoon award. Stacy says it's 1/4 of 10 rather than 10 groups of 1/4. You're exactly right. And one of the things that we need to identify is the fact that when we give kids fractional multiplication questions, we ourselves have to pause and to think about how can kids really enter into this. Now, I want to go back to Jennifer mentioning that indeed it is division. Kids get this, and what they know to do is they know to take 10 and divide it by 4. This opens it up for what beautiful conversation happens to be that inverse relationship, right? Is 10 divided by 4 the same thing as 10 multiplied by 4? And this whole problem really gets to that. So I'm going to propose to you some good student work. Look closely at your screen. In the information that I gave you, you actually have good examples of student work. Look what this little pumpkin did. They took 10. I can see the half mark here. And then they said, all right, here's half here and half here. So that's 2.5, 5, 7.5. And so I begin to see what the kid is thinking in this way. And so I love that. Notice I put the love there for that. Another example is this one right here. Chris bakes 24 cookies. He uses 3/4 of the batch of cookies in treat bags for his birthday party. Again, Stacy, tell me again, why is this one different? It's different, right? This one's different.
Right, because again, you're not thinking, it's division, right? You're thinking 3/4 of 24 rather
Very
than
good.
24 groups of 3/4.
You got it. You got it. And I need us to really acknowledge that in this, the takeaway that I want us to have is that there are different ways of thinking about this multiplication, and we must attend to that. So that's so important. I'm watching my time, so I'm going to hurry through. You can see that these again have some examples of student work. So this is what I love about this, is that not only is it a question, but it reminds me as a teacher what we should be looking at. And I said, look right here, because I almost missed it. So this student thought about Chris, and he thought about 3/4, and he knew what 3/4 looked like. And so it was, this is the part I need, and then that's the part I don't have. And then he knew his 24. So he said 6, 6, 6, and 6. And so therefore 3 of those 6s gives me 18. And so I almost missed it in the student work. And look, Amy said I was drawing cookies too. That's exactly right. That's exactly right. This is why these sessions need to be way longer, so that I can see your student work. Remember, you're kind of gathering up some things that you're learning as we're going along here. So this is where I'm going to end, because I'm going to be very mindful of my time. And that is, Lamont talks to us and says that fractions, one of the ways to think about fractions is as operators. The fact that a fraction transforms a number. It either lengthens or shortens, increases or decreases the number of items, or in middle school, it takes a geometric shape and it makes it larger or smaller, and then therefore we get to similarity and scaling. So think about, I put some questions in here. I'm gonna hurry past that because of my time. But one thing that I want you to know is that, look right here. Troy has 1 2/5 as many baseball cards as I have. I have 55 cards. How many does Troy have? Well, interestingly enough, I'm just going to divide the 5 into 55 because I want to know what 1/5 is, because this to me is 7/5. So as long as I know what 1/5 is. But in this one, we can multiply by 5 to make this one easier. Multiply by 5 and divide by 6. Or in this case, we can divide by 5 and then multiply by the 7. One of the things that was so powerful with the Lamont book was to say to myself, look, it doesn't matter whether I multiply or I divide first, because it's an operator. It is a composite fraction. It kind of multiplies into, but this is what makes fractions difficult. I've got some more videos in there for you. I've got some great pictures for you guys from the Van de Waal book, and thinking about those area models, because oftentimes we think about the area model as a discrete area, but it can also be sets of dots and thinking about what that looks like. I adored this picture, so I took a picture of that and added that in for you guys. So this is very powerful. And so I'm going to pause for a moment and think about this teaching tip from some people that we really admire. Some textbooks make the sliced rectangle approach mechanical, meaning the area model mechanical, and that it becomes a meaningless algorithm itself. Right? I'm going to pause and say, be careful of that. We should not be teaching conceptual models, such as the area model for multiplication of fractions, and all of a sudden it becomes this, do this many lines this way, do that many lines this way, shade in this. Notice what he says, shade in the first one, then it's the double shaded that actually happens to be the answer. And it still is no more nonsensical than the actual rule itself. So we need to circle back to division because I am out of time, but Graham Fletcher's one of our favorites, and he's got a great video in here for you guys to take a look at. But I want to give just a minute to think about the three things or the three words that maybe you captured today from our learning experience. My goal was to encourage you to teach every bit of multiplication of fractions in context. There's not a, that was a goal that I had for you. Another goal was to think about how we apply and extend. And then I shared some resources with you. So in the chat, I'm gonna see that there's 28 of us on here this afternoon, and so I thank you so much. What are the three words or the three things? Kim Smith says it is the apply and extend, it's the engagement, and it's the real world context. Thank you, Kim. I appreciate that you're really thinking about this. Bill, you're right. It's that seeing the inverse operation for that fraction. Was it divided by 4? Or was it multiplied by 1/4? I'd love to hear from some of you. You can go ahead and unmute and share.
I like that you talked about how they need to understand the concept before they do the algorithm, because I know even in like first grade classrooms, we've had teachers give their kids these algorithms of like balancing equations, which is algebra and really hard for first grade, and they don't really understand the concept, and there's not pictures or anything to go with them. So I like that they, understanding the concept before they do the algorithm.
You're exactly right. And do you know that extends all the way up through high school? So Leah's on today. She's our high school expert here at the KCM, and it's 100% true with them too. We should not be teaching math without the concept. Lisa loved the pattern block example. If you hang with KCM enough, Lisa, we'll get you pattern blocks to be able to use not only for the K2 classrooms, but we use them probably more and more in our intermediate. So fantastic. I see all of those three words coming in. Indeed, Mary Kate says it indeed does extend their thinking, and Rachel says engaging, context, and visual, and that's exactly right. That's how we should do it. So next week is developing geometric thinking. We again do a progression, and I know that you'll be with us. If you're here with us on a Friday afternoon, you will be with us at the first of the week when we've got some great stuff for you. You can always find us at the KentuckyMathematics.org website. It houses all of our virtual information and more. And then most importantly, you can find me at NKU here at the Kentucky Center for Mathematics, housed at the NKU. And I want to thank you so much for spending your afternoon with me. I look on there and I see, there's my people. I see Kathy, I see Jennifer. We are from all kinds of places here in Kentucky and across the nation. And so I thank you for spending your Friday afternoon with me.
And this is Dee. And so if anyone wants to give Kelly kudos, thank you all for dealing with our technical issues early on. And thank you for being with us this week.
All right, fantastic. We thank you. I see all your thank yous in the.
Yeah, sorry, this is Jennifer from Austin. I got on late today and I did enjoy the bit I got, and I look forward to rewatching the beginning part, but I did like that how you were progressing. And I mean, I love anytime that people make sense of math. Math is the one subject that should always make sense. So why we teach it any other way, I don't know. So thank you so much. Y'all are doing a great job. I appreciate it.
You
And have a
got
great
it. Thank you, Jennifer. That's some kudos from Texas, and we appreciate that. Again, Amy says fractions are stumbling blocks for so many people, and it gets in the way of everything. So we just really encourage you guys to settle in. Jacqueline liked the student work. I did too, Jacqueline. I love to look at student work just to get in their thinking. From us to you, from the Kentucky Center for Mathematics, you know when, 2 o'clock. We'll see you on Monday at 2 o'clock. Thank you.